So here I'm just walking through my code, showing some pretty basic stuff. It's just the addition of the forces, essentially. And then here's it playing. It's just a basic projectile motion, kind of flying through the air. I'll cut it off here in a second and go on to the next one. Now this one, I changed the force to a different force, just to show that it can go stronger or less powerful, I guess. Here I changed it down to 30, from 70 to 30, and now I'm changing it back to, I think it's 80, maybe 90 or 100, but here, now it's so powerful that it's gonna go off screen, so that one just shows that it can change. And here I changed I commented one line that fills the screen with white every frame, so now it can draw out the parabola that the projectile follows. We start out with just gravity. Then we gain our forces, where they come from, and their components. So velocity is our main force, going in the direction of Vx and Vy. Theta is the angle at which the projectile is ejected. And Vx and Vy are determined by some simple trigonometry multiplied by the force. And Vx degrades by drag, while Vy degrades by gravity. And what I just explained about the forces is the same way that I calculate them in my program. I just use the force that is inputted multiplied by the cosine or sine of the angle, and since I didn't include drag in this very basic simulation that I did, I just used gravity to degrade Vy, but Vx will just go on. It's constant, essentially. So that's the same formulas that I use. There are other ways to do it, like if you happen to know exactly the components of your force that you put into your projectile, then you can just input those with simple modifications to the code, and it will give the same result. So that works too. So here I've added a little vector thingy to track it doesn't actually track the velocity, but it kind of demonstrates the vectors of Vx and Vy components of your total velocity. So I added that there. The way I got this video was by using my GoPro, and I just tossed a bouncy baseball off a balcony in my house, and I recorded it in slow-mo and played it back for you. I'm going to get into the physics part a little bit more now. When something falls a projectile motion equation, it will always form a parabola, or technically an ellipse, but very close to a parabola. And it forms that, I think, because the derivative of a parabola is just a linear equation. And if there was no gravity or air resistance, it would be a linear equation. But since there are, that adds like an extra dimension or something. I'm not entirely sure there, but it does form pretty much a parabola. And the way that you calculate Vx and Vy, or the components of your velocity in the x and y direction, for Vy, at your timestamp, you take whatever velocity you have, and you subtract your gravity constant from it, which is on Earth roughly 9.817 meters per second squared. And for Vx, you just subtract your drag deceleration. There's a whole kind of aerodynamics and equation for drag and stuff, and you do that for Vy too. Because if it's got a negative velocity in Vy, then you subtract, or then you add the drag too. But then for collision, you usually just send it, in a basic simulation, you just reverse its velocities or the y velocity at least. Also, guys, just a note, if you're watching this and you think I deserved a like or maybe a subscribe, that would be great, or even just a share to somebody else that you think would enjoy this. Bye.